in Ahle High School and the Junior College. Welcome to the series of the lectures of Intermediate First Year Maths A. We started our discussion with Principle of Mathematical Induction. What did we learn in this? In that chapter, we did two problems in which we discussed the three steps. That is, the first step will be substituting n is equal to 1 and we have to prove for n is equal to 1. And in the next step, we will assume that the P of n is true for n equal to k. Third step, we have to prove that P of n is true for n is equal to 1, right? With the reference of the all three, we will prove that P of n is true for all of n. Okay, shall we do a few more problems of same question? Fine, see here. The next question given here it is, he is asking us to show that 1 by 1 into 4 plus 1 by 4 into 7 plus 1 by 7 into 10 and so on up to n terms is equal to n by 3n plus 1, right? Is it similar to the last problem? Yes, right? But the only difference is, whatever the terms we have, it was only in the numerator, right? Here we have everything in terms of fractions. Okay, fine. What is the first step we have to do? We have to segregate these terms as two different APs, 1, 4, 7 and so on for one AP, 4, 7, 10 and so on as second AP, right? What is the first term here? 1. What is the first term here? 4. What is the common difference? 4 minus 1 is 3. This is D. What is the common difference here? 7 minus 4, that is 3. Okay. What is the nth term? A plus n minus 1 into D. Here also an is A plus n minus 1 into D. Okay. Now here 1 plus n minus 1 into 3. Here 4 plus n minus 1 into 3. That is 1 plus 3 into n is 3n minus 3 into 1 is 3. 1 minus 3 is minus 2. Here 4 plus 3n minus 3, that is 3n plus 1. Okay. Therefore, what is my nth term? Tell me. Both are in the denominator, right? This into this. 3n minus 2 into 3n plus 1. Okay. Now, what is the first step we are going to do? We will assume let P of n be 1 by 1 into 4 plus 1 by 4 into 7 and so on up to 1 by 3n minus 2 into 3n plus 1, that is equal to n by 3n plus 1. Is it right? Fine. What is the first step now? Step 1 will be put n is equal to 1. Now tell me what is LHS? 1 by 3 into 1 is 3 minus 2 into 3 plus 1. 3 minus 2 is, how much is it? 3 minus 2, that is 1 into 3 plus 1 is 4, that is equal to 1 by 4. What is RHS? That is 1 by 3 plus 1. That is 1 by 4. Both are same, right? Therefore, P of n is true for n equal to 1. This will be my first statement. Okay. Now, what will be the second statement? That is, we have to assume P of n is true for n equal to k. Yes, that is P of k is equal to 1 by 1 into 4 plus 1 by 4 into 7 and so on up to, what is nth term? 1 by 3k minus 2 into 3k plus 1. 3k minus 2 into 3k plus 1, that is equal to k by 3k plus 1. This is my second statement. Is it fine? And the next, what is the third step? Which is very important and which is very confusing to solve, isn't it? That is, we show that P of n is true for n equal to k plus 1. Isn't it? Just substitute the value of P of k plus 1. What is that we have to do? Tell me. I know that this whole term is P of k and the next term is substituting k plus 1 in this term, right? Just substitute k plus 1 here. What is that you are going to get? 3k plus 3 minus 2 into 3k plus 3 plus 1. Plus this will be as it is. This you already know. Right? Yes or no? Now just see here. 3 minus 2 is 1. Therefore, this becomes as 3k plus 1 into here 3k plus 4. 3k plus 4 plus here k by 3k plus 1. Okay. Now take the LCM for 3k plus 1. That will be LCM is 3k plus 1 into 3k plus 4. Here in the numerator, what will be the thing? This both things we have written here. The left out is 1 plus k into 3k plus 4. That is 1 plus k into 3k is 3k square plus 4 into k, 4k divided by 3k plus 1 into 3k plus 4. Okay. Now can we solve this 3k square plus 4k plus 1? We can factorize it, right? Now simplify it. 3k square plus 4k can be written as 3k plus k plus 1 by 3k plus 1 into 3k plus 4. Right? Can I take 3k common from the first two terms? Yes, right? That will be 3k into k plus 1 plus 1 into k plus 1 divided by 3k plus 1 into 3k plus 4. Now again k plus 1 take it as common. You will be left with 3k plus 1 divided by 3k plus 1 into 3k plus 4. These both will get cancelled. What is left? K plus 1 divided by, can I write 4 as 3 plus 1? So we can take it as k plus 1 as common plus 1. Right? Is it not same as in the question? Yes, right? Fine. Therefore, P of n is true for n equal to k plus 1. Therefore, from 1, 2, 3, P of n is true for all n belongs to n. Is it right? Is this question easy? We are solving different varieties of problems. We started with the single term, we started with the two terms, and then we solved by taking two terms in the denominator. Okay. Now let us move to the next variety of the problem. Till now, whatever the varieties which we saw, those were always numbers, right? Now what the question which we are going to solve is only variable term, right? This kind of question is very popular, however you know that. Till now we used the formula of AP, now we are going to prove the statement of AP. That is A plus D plus A plus 2D and so on up to A plus n minus 1 into D is equal to n by 2 into 2A plus n minus 1 into D. Right? This is my nth term and this is my sum of n terms. Right? This question we have to prove now. This is very easy to solve and very important. Okay? Fine. When we consider the base, when we consider it as a basic statement, fine, an is given. Yes, okay. That is, what is the first step of my proof? That is, let P of n be a plus D plus A plus 2D and so on up to A plus n minus 1 into D is equal to n by 2 into 2A plus n minus 1 into D. Fine. What is my first step now? Step 1 is put n is equal to 1. Okay. That is LHS is A plus 1 minus 1 into D. That is A plus 0D, that is equal to A. Okay. What is RHS? RHS is 1 by 2 into 2A plus 1 minus 1 into D plus half into 2A. 2 cancel, the left is A because this will be 0D. Fine. LHS is equal to RHS. Yes, right. Therefore, P of n is true for n is equal to 1. Okay. And what is the next step? Step 2, however we know that is assumption. What is that? We have to assume that this statement is true for n is equal to k. Okay. That is assume P of n is true for n is equal to k. That is, P of k is equal to a plus d plus a plus 2d and so on up to a plus k minus 1 into d is equal to k by 2 into 2a plus k minus 1 into d. Is it not? Right? Fine. This will be my second statement. What is my third statement? That is, step 3 will be, now we show that P of n is true for n equal to k plus 1. Okay? P of k plus 1th term. What is it? Right? Just k plus 1th term of this nth term. That will be a plus, instead of k we have to write it as k plus 1 minus 1 into d plus, this is k by 2 into 2a plus k minus 1 into d. Okay. Now plus 1 minus 1 will get cancelled, kd. Here k by 2 into 2a plus k minus 1 into d. Okay. Now let us take LCM and let us simplify. What do we get? Okay. Now see here LCM is 2, multiply 2 to here, 2a plus 2kd. 2a plus 2kd plus k into 2a plus k minus 1 into d. That is k into 2a plus k minus 1 into d. Fine. Okay. Now let us write it, 2a plus 2kd plus 2ak plus k into k minus 1 into d whole divided by 2. Okay. If you observe here, 2a plus 2ak, can I take as 2a common? I will get it as k plus 1. Okay. And then here kd common, I will get it as 2 plus k minus 1 whole divided by 2 again. Now here 2a into k plus 1 plus here kd into 2 minus 1 is plus 1 divided by 2. Can I take k plus 1 common? Yes, right. Therefore, that will be k plus, instead of k, can I write it as k plus 1 minus 1? Yes, right. Yes or no? Therefore, this is not the same as this question. K plus 1 by 2, 2a plus k plus 1 minus 1 into d. Yes, fine. Therefore, P of n is true for n is equal to k plus 1. Therefore, P of n is true for all n belongs to n. Is it not right? Even it is a variable kind of question, we can solve a bit. Isn't it? Shall we move on to the next problem? Let's do. This is one more variety of the question. Till now, we have seen the questions with the mathematical statements. In this, we are going to have a simple given statement. That is, this is a generalized statement where this is a term which is always divisible by 64. Right? How do we prove? The same step. Whatever we do, we have to assume P of n as 49 power n plus 16n minus 1 is divisible by 64. Okay. Now, step 1 is put n is equal to 1. Okay. Now, let us write only LHS, that is 49 power 1 plus 16 into 1 minus 1. Okay. 49 plus 16, that is 65 minus 1, therefore this is 64. Yes, therefore P of n is true for n is equal to 1. Okay, what is the next step? Step 2 is assumption. Assume P of n is true for n is equal to k. Is it fine? That is, P of k is equal to 49 power k plus 16k minus 1, that is equal to 64k. Right? Because that is divisible by 64. Just write this. Just remember this. Okay, or else you can let us write one more statement is divisible by 64. Therefore, from this we can write it as 49 power k plus 16k minus 1 is equal to 64 into some number, let us say some m. Okay, 64 into something, right? Fine. From this, can I write it as 49 power k is equal to 64m minus 16k plus 1? Yes, right? Fine. Now let us write the next step. That is, now we show that P of n is true for n equal to k plus 1. Okay, that is, okay, let us write it here. P of k plus 1 is equal to, we have to substitute n equal to k plus 1 here. That will be 49 power k plus 1 plus 16 into k plus 1 minus 1. Okay, let us multiply each and every term. This, can I write 49 power k plus 1 as 49 into 49? Yes, right. Then let us multiply these both, 16k plus 16 minus 1. What is 49 power k? Just tell me. That is 64m minus 16k plus 1. That is 64m minus 16k plus 1 into 49 plus 16k plus 16 minus 1 is 15. Is it right? Let us multiply each and every term now. That is 64m into 49 minus 16k into 49 plus 49 plus 16k plus 15. Is it okay? Now let us take 64m into 49 as it is. I mean 64m into 49 minus k terms. Can I take 16k common here? Yes, right. If I take 16k common, here it is 1 minus 49, that is minus 48 plus 49 plus 15. Now tell me 64m into 49 minus, can I write this 16 into 48, if I want to write the whole thing in terms of 64, right? Can I write it as 64 into 16, what's the 64? 16 4s are right. What is left? And the next, that is 12k is left, plus 49 plus 15 is again 64. Now just take 64 common. 64 into 49m minus 12k plus 1. Therefore, 64 into something. Yes, right? From this, therefore, P of n is true for n equal to k plus 1. Therefore, P of n is true for all n belongs to n. Is it right? Is it not easy? Yes, right? Fine. These are the variety of problems of mathematical induction. Let us meet in the next session with the more problems of mathematical induction.